Hello, ladies and gentlemen. We're going to review matrices. All right, let's start with the dimension of a matrix. The dimension of a matrix, is the number of rows by the number of columns. Okay, if you look at matrix A, there's 2 rows going across and 2 columns coming down. So the A is a 2 by 2. So that's a 2 by 2. B is also a 2 by 2. Matrix C has 2 rows, and, 2 rows. All right, 2 rows and 3 columns. 1, 2, 3. Matrix D has 3 columns. 3 rows and 2 columns. Matrix E is what's called a 2 by 3 because it has 2 rows and 3 columns. All right, so what are the dimensions of matrix D? Well, matrix D is right there. That is a 3 by 2 matrix. All right. Now, transposing a matrix. When you transpose a matrix, row 1 will become column 1, and row 2 will become column 2, and so on. So if we're going to transform D, then column 1 will become row 1. So 2, -4, and 3. And column 2 will become row 2. So 0, 3, 2. And now you can see that row 1 became column 1, and row 2 became column 2, and row 3, oh, this should be a negative, my fault. All right, row 3 became column 3. All right, so that's what we mean by transposing. That little T right there means to transpose the matrix. In other words, exchange the rows with the columns, or the columns with the columns with the rows. All right, to add 2 matrices, all right, they must have the same dimension. All right, so if they don't, you cannot add them. All right, let's look at adding matrix C, which is a 2 by 3, with matrix D, which is a 3 by 2. 2 by 3 and 3 by 2 are not the same, so what we say there is that is not possible. E, we're trying to add the E. Yes, those are possible, excuse me. All right, if we're adding C to E, they're both 2 by 3 matrices, all right? And when you add matrices, you have to add corresponding entries, all right? In matrix C, row 1, column 1 entry is 3. Row 1, column 2 entry is 2. Row 1, column 3 entry is 1. Row 2, column 1 entry is 1. Row 2, column 2 entry is -2. And row 2, column 3 entry is 6. So when we add C to E, we take row 1, column 1 entry 3 and add it to row 1, column 1 entry of E, and 3 plus 5, that gives us 8. And then we take 2 plus x, that gives us 2x, all right? And then we do 1 plus 3, that gives us 3. And then we'll add the next row, row 2, column 1, 1 plus the same entry over here, 0, gives us a 1. All right, and then -2 plus 7 gives us 5. And then 6 plus y plus 1 is y plus 7. All right, and there we have added each of the corresponding entries. All right, let's see if we can do number 4. Number 4 says to add D to C. Well, D is a 3 by 2. C is a 2 by 3. Those are not the same. All right, so that is not possible. Okay, and you might want to say not possible. And the reason is that's a dimension mismatch. They have to have the same dimensions, which they do not. All right, now let's go down to number 5. All right, in number 5, we're going to multiply by a scalar. I don't know if you remember this, but if you see a number out in front of a matrix, that means you're multiplying each and every element of that matrix by that scalar. So that B is going to be multiplied by 2. All right, and that means that I'm going to do 2, and I'm going to write this work down here. 2 times negative 5, 2, negative 7, 3. And you can do this if you want. That's what I would do, so that I'm adding. All right, and then I'm going to do plus negative 3 times a, which is negative 3, 2, negative 7, 5. All right, and I'll do this work so you can see this, okay? All right, so when I multiply by 2 to this to the matrix that's B, I would get negative 10 for row 1, column 1 entry. Excuse me. I would get positive 4 for row 1, column 2, negative 14 for row 2, column 1, and positive 6 for row 2, column 2 entry. And then I'm going to add to that negative 3 times each in the other here. So when I multiply row 1, column 1 entry by negative 3, I get 9. When I multiply row 1, column 2 entry 2 by negative 3, I get negative 6. All right, and negative 3 times negative 7 is positive 21. And then negative 3 times 5 is negative 15. And now I'm just adding a 2 by 2 to a 2 by 2. And that means I'm just going to add the corresponding entries. Negative 10 plus 9 is negative 1. Okay, all right. And then I would do 4 plus negative 6, that's negative 2. And then negative 14 plus 21 is 7. And then 6 plus negative 15 is negative 9. All right, let's go to number 6. In number 6, we're going to multiply matrices, okay? All right, and I'm going to write out that process just to make sure we see how to do that. In order to multiply matrices, you need to look at the dimensions, and it's a row by column, and you want to multiply row by column times row by column. If you do that, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. If that's not the case, then it's not possible. All right, and C is a 2 by 3. Okay, we're going to take a 2 by 3 and we're going to multiply it times matrix D, which is a 3 by 2. And as you see, the number of columns in the first matrix is equal to the number of rows in the second, and that means it's possible. And when you multiply that, you're going to get a 2, which comes from right here, by 2 matrix. That's what you're going to end up with, is a 2 by 2. All right. Yeah, these have to be the same right here. If they're the same, you can do the multiplication, and your result is going to be whatever this is times by whatever that is. Okay, so let me write that down here. All right, we're going to take C. All right, I'll write that over here. C is 3, 2, 1, and 1, negative 2, 6, and we're going to multiply that times D, which is a 2, negative 4, 3, and 0, 3, negative 2. All right. So when we do that, we're going to take the first, we're going to take this first column and multiply it times that first row right there. So that would be 3 times 2 plus 2 times negative 4 times negative 4. Let's just use parentheses. That might be easier. Plus 1 times 3, all right, to get row 1, column 1 entry. Okay, then we would take, excuse me, for the next one down here, we would do, let's see, we would do okay. All right, we need that. I'm going to separate these rows and these columns because I'm going to end up with a 2 by 2. All right, so then we would take this same column and multiply it times this row, okay? All right, so that would be 1 times 2 minus 2 times negative 4, all right, plus 6 times 3. Okay, all right. And then we'll take this column and multiply it times the first row. So that would be 3 times 0 plus 2 times 3, all right, plus 1 times negative 2, okay? And then we'll take this second row and do it times this one. So that would be 1 times 0 minus 2 times 3 plus 6 times negative 2. Okay. All right, so now we're going to simplify these products first of all. 3 times 2 is 6, and 2 times negative 4 is negative 8, and then 1 times 3 is 3, that's plus 3, excuse me. All right, that'll give us that one. And then we'll do 1 times 2 is 2, and negative 2 times a negative 4 is positive, and that's positive 8, plus 3 times 6 is 18. All right, so once again, I'm going to separate these, all right, with dotted lines. You don't have to do that, but I like to do that. That product is 0, all right, plus 6 plus negative 2, or minus 2. You could write it either way. And down here, we would have 0 minus 6 minus 12. Okay, and now we can simplify these. As first one, 6 plus negative 8 would be negative 2, and negative 2 plus 3 would be positive 1. Okay, all right, and this is going to be a matrix. Let's put that matrix. It's a 2 by 2. All right, so that would be a 1, and then 2 plus 8 is 10, and 10 plus 18 is 28. All right, then we'll come over here. 0 plus 6 is 6. And 6 plus negative 2, or 6 minus 2, is 4. All right, 0 minus 6 is negative 6, and negative 6 minus 12 is negative 18. All right, there we go. We're finished with that product. Let's go down to number 7. In number 7, we're going to try to multiply two matrices. Now, B is, as you can see right here, a 2 by 2. So B is a 2 by 2, and D is a 3 by 2. A 3 by 2. Well, if we're going to multiply these two numbers have to be equal. The number of columns of the first and the number of rows of the second matrix. They are not equal, so this one is not possible. Not possible. And you can say dimension mismatch if you like. Okay. Mismatch, M-A-T-C-H, excuse me. All right, let's go to number 8. In number 8, B is a 2 by 2. So we're looking at multiplying a 2 by 2, and E over here is a 2 by 3. 2 by 3. Well, look at the number of columns of the first matrix and the number of rows of the second and compare. Are they equal? The answer is yes, okay? And since those are equal, the result is going to combine to give you a 2 by 3 matrix. Okay, so I'm going to come over here and I'm going to write this down over here. Okay, so B is negative 5, 2, negative 7, 3. All right, and we're going to multiply that times E, which is a 5x3 for row 1, and then row 2 is 0, 7, y plus 1. Okay, all right, so then we're going to take this first column, and I'm going to go ahead and, what I'm going to do is, I know that I'm going to end up with a 2 by 3, so what I'm going to do is I'm going to stretch it out. I'm going to say, okay, I've got 2 rows. Okay, and then I've got 3 columns. One, I'm going to separate it. It kind of helps me do that if it's not required, but it might help you. Okay, so I'm going to take this first column and multiply it times this first row. So that would be negative 5 times 5 plus 2 times 0. Okay, and then I'm going to take that one and multiply it times the second row, which would be negative 7 times 5 plus 3 times 0. Okay, then I'm going to take this second column and multiply it times each row. So negative 5 times x, all right, plus 2 times 7. Okay, all right, and then I would do negative 7 times x plus 3 times 7. Okay, and then we'll do the last row. We would multiply negative 5 times 3 and add to that 2 times y plus 1. All right, and then we would do negative 7 times 3 and add to that 3 times y plus 1. All right, so then we're going to simplify this a little further here. Okay, all right. And like I said, we got a 2 by 3, so I'm just going to go ahead and separate it out. It doesn't hurt to do that. Doesn't bother anybody. All right, so this first product is negative 25. Okay, so negative 25 plus 0. Okay, and this down here is negative 35. You can do the rows or the columns, it doesn't matter, plus 0. Okay, all right, and this is negative 5x plus 2 times 7 is 14. This is negative 7x plus 21. All right, and over here is going to be negative 15. Negative 15 plus, down here we got to distribute, so that would be 2y plus 2. And down here we would get negative 21 plus 3y plus 3. Okay, now we're going to simplify each one of these, and we're going to end up with, like I said before, a 2 rows and 1, 2, 3 columns. Okay, so this row 1, column 1 entry would be negative 25. Negative 25. This row 2, column 1 entry would be negative 35. Okay, over here we would get, let's see. Oh, wait a minute. I think we forgot an x. Yeah, it looks like we forgot our x over here because there was an x involved there. So that's negative 5x plus 14. All right. Or you could write 14 minus 5x. It wouldn't matter. Same thing either way. All right. And then when we combine the, let's go ahead and do this. So negative 7x plus 21 or 21 minus 7x. It's the same thing. Okay. Oops, I can't write that small. Over here, we can combine these two constant terms and do 2y minus 13, okay, or negative 13 plus 2y, same thing. And down here, we'll combine these two constant terms and get negative 18. So that would be 3y minus 18. Now, that's kind of small, but that's how you do that problem. We're going to turn the page. All right. Next, it says use the following matrices for problems 9 through 13 is what it should say. Let's put that, make that a 9. Show all work by hand and check with the calculator. Okay, so we're going to check that work with the calculator. And we're going to do it by hand first. Okay. Now, this C2 means matrix C, column 2, or row 2, column 2 entry, which is negative 2. So C sub 22 is negative 2. Okay, all right, plus, now the D means we go to matrix D, and the little sub 31 means to go to row 3, okay, column 1, and get that entry. That entry is 3. So that would be 2 plus 3 minus, now we're going to go to matrix B, all right, go to matrix B, all right, and we're going to locate, here's matrix B, row 2, column 1 entry, which is negative 7. All right, but when you subtract a negative, that's the same as adding a positive. So we're looking at negative 2 plus 3 plus 7. I'd go ahead and add 3 and 7, get 10. So that'd be negative 2 plus 10, negative 2 plus 10, which would be, I do believe that's equal to 8. So we'll put that over here. So that value is equal to 8. Okay, now this little subscript of 2 means that you're going to square that matrix. You're going to multiply it times itself, okay? So we're going to take B, all right, which is negative 5, 2, negative 7, 3, and we're going to multiply it times itself. All right, negative 7, 3. All right, now, first of all, anytime you square a matrix, it's not always possible, but unless it's a square matrix, which means it has the same number of rows and the same number of columns, which this A is, all square matrices will be squarable. All right, so let's do this first. We're gonna end up with a 2 by 2, so I'm gonna just make my location here for a 2 by 2, if that's all right with you. It's not required, but you can do it if you want. It kind of helps you organize things. And now I'm gonna take this first column of that second matrix and multiply it times the first row first. So negative 5 times negative 5 plus 2 times negative 7. And then I would do negative 7 times negative 5 plus 3 times negative 7. Okay? All right. And then I would take the second column and multiply it times the first row. So negative 5 times 2 plus 2 times 3. 2 times 3. And then I would do negative 7 times 2 plus 3 times 3. Okay, so then this would be equal to, and once again, it's going to leave me with a 2 by 2. All right, so there's my spot. This first product, excuse me, this first product right here would be positive 25, all right, minus 14. Okay. Negative 5. Oh, I think I squared B. Well, we're going to change this to B. I'm sorry. I took B when I should have did A. But that's okay. It's not going to matter. Well, we'll change that to a B, and it'll be all right. So 25 minus 14. All right. And down here, this one would be 35 minus 21. All right. This product is negative 10 plus 6. Okay. And this product is negative 14 plus 9, okay. All right, 25 minus 14, that's 11, so row 1, column 1 entry is 11. 35 minus 21 is 14, okay. And this should be a 4, all right. And that should be a negative 5. Ooh, that should be negative 4, my fault. And this one would be negative 5. All right, now, to do this on the calculator, what you need to do first is to take your calculator, all right. I just like to clear the RAM is what I like to do to start with. That way I don't have any doubts about what's in my calculator. And then if you press second, come down 1, 2, 3 buttons, there's your matrix button. We're going to first edit. And since I did B, I'm going to do number 2, which is B, okay? And it is a 2, so 2 enter, and then by 2, hit enter again. The row 1, column 1 entry was negative 5. Now where did it go? It went to row 1, column 2, so that's the 2, okay? And then it goes down to row 2, column 1, which was the negative 7, okay? And then row 2, column 2 entry is 3, so hit 3. Now, this calculator is kind of funny about dealing with matrices. You got to get out of this matrix editor, so press second quit to go back to the home screen. And now, what we're going to do is we're going to do that matrix B squared. Okay. All right. So we're going to get the name of the matrix. So go to second matrix, and we want the name. Well, we did number 2, which was the B, and then we're going to square it by hitting the square button. And when we come back, we should get 11, 14, negative 4, negative 5. Okay? Sorry about squaring B instead of A, but it's done the same way. So if you can do B squared, you can do A squared. All right. Now, the next one down here says to do D times the D transposed. Okay? All right. So, first of all, D, all right, and I'm going to see if this is possible, first of all. D is a 3 by 2. Okay, all right. D transpose would be a 2 by 3 because you're going to switch the number of rows and the number of columns, a 2 by 3. Okay, and if it's possible, we'll do it. If not, we're not going to mess with it. Is the number of columns of the first matrix equal to the number of rows in the second? And the answer is yes. And when you finish, you're going to get a 3 by 3 matrix. That's what your result will be. The number of rows from the first and the number of columns from the second. Okay. All right, so this is possible, and that means I'm going to write down D. So I'm going to do D, which is 2, negative 4, 3 for column 1, and 0, 3, negative 2 for column 2. And then I'm going to multiply that times. This time I'm going to transpose that. So when I transpose it, and by the way, I'm going to show you with the calculator. We're going to check this with the calculator anyway. But this, if you want to transpose on a calculator, you can. I'll show you that. If you, first of all, let's clear out whatever's on the calculator. Do second matrix, okay? And let's just go, which one we're doing? We're doing D. Okay, we'll do D. All right, since that's the name of this matrix, we'll put in D. All right, excuse me. All right, so second matrix, we're going to edit because D's not in there right now. All right, D is a 3 by 2, so 3 enter, 2 enter. You have to put the dimensions in first when you edit. All right, and so 2 enter, 0 enter, -4 enter, and 3 enter. And then 3 enter and -2 enter. Let me make sure. The first column is 2, -4, 3. Second column 0, 3, negative. And then first row is 2, 0. And -4, 3 for the second row. And the third row is 3, -2. So we're good. Okay. Now, if you will do this, if you will come out and then call that matrix name up. Let's do second matrix. And we put in, oh, did I put it in A? Oh, that's terrible. Okay, look. Let me go, I'm going to do this. I'm going to go second quit. I'm going to go back out and I'm going to do second plus 7, 1, 2. And I'm going to put this matrix in D because I want to use the same notation that's on the paper. Okay, so I'm going to go second matrix, not test, excuse me, second matrix. I'm going to edit and I'm going to edit D, which is number 4. Okay, and it is a 3 by 2 matrix, and it won't take me but just a second to re-enter those values. Okay, 3 and then 3 again and then -2. Okay, so now I've got it in D instead of A or whatever. It really wouldn't make much difference, I'll tell you right now. Okay, but I'll do that. So if you want to transpose a matrix, if you would do a second matrix and call the name of the one you want to transpose. All right, right here we're in the name, so the one we want to transpose is D. And then I think if you want to transpose it, if you go back into the matrix editor menu and go to math, transpose is number 2, and it will transpose it. And by the way, what that means is it's going to make row 1 will be column 1. All right, so row 1 will be column 1, and I'll hit enter on that in a minute. So row 1, which is 2, 0, will be column 1. Row 2 will be column 2, -4, 3. And row 3 will be, whoops, I need to bring that down. Hold on one second. Let's bring that down a little bit. 3, -2. All right, so that's what's going to happen when we hit transposed over here, by the way. So we did it by hand first. So 2, -4, 3 will become the first row, and which since it was the first column, and 0, 3, -2 will become the second row. Okay, now one more thing about this matrix calculator stuff. You can, I believe you can transpose or name that. Let's see. Can you store? Let's see if it'll let us store in alpha, y. Let's store that in 1. Let's see if it'll let us do that. Oh, it did. Okay. So now what I did is I put D transposed in A is what I've done. All right. And that way, when I go back to check it in a minute, I won't have to re-enter it, even though I could. Okay. All right. Now we're going to do it by hand first. So we know that we're going to have a 3 by 3. So what I'm going to do is I'm going to say, okay, oops, I didn't need that. I just need this right here and that right there, and we'll erase all that I don't need. Okay, sorry about that. Okay, so we're going to have 3 by 3. All right, so we're going to come across here and make 3, and then we'll do the same vertically. We'll make 3, and then we're going to say, okay, it's 2 times 2, all right, plus 0 times 0, -4 times 2, all right, plus 3 times 0, 3 times 2 plus -2 times 0, all right, and then we'll do this next column here, all right, so that would be 2 times -4, all right, plus 0 times 3, all right, and then -4 times -4, all right, plus 3 times 3, all right, and then we would do 3 times -4 plus -2 times 3. Okay, all right, and now for the last one, we would have 2 times 3 plus 0 times -2. And then we would have -4 times 3 plus 3 times -2. And then last, we would have 3 times 3 plus negative 2 times negative 2. All right, I think we got it all in there now. Okay, so then we would have our 3 by 3 down here. So we're going to have 1 separated into that, and then we'll do 1, 2, 3. And you don't, like I said, you don't have to do that. I'm going to do all this calculations here real quick. That would be 4 plus 0. 4 plus 0. This right here would be negative 8 plus 0. Negative 8 plus 0. This would be 6 plus 0. 6 plus 0. All right, 2 times negative 4 is negative 8, and 0 times 3 is 0. All right, and then negative 4 times that's 16, so 16 plus 9. 3 times 3 is 9. All right, excuse me, and then this would be negative 12 plus negative 6, so negative 12 plus negative 6. This would be 6 plus 0. 6 plus 0. And this would be negative 12 plus negative 6. And this would be 9 plus positive 4, excuse me. All right, and now when I add that first one right there, okay, I get 4. So that is going to be, here's going to be my matrix. My first row 1, column 1 entry is 4. All right. Row 2, column 2 entry would be 8 plus 0, which is negative 8. And then 6 would be row 1, column 3 entry. All right, and then negative 8 plus 0 is negative 8. And 16 plus 9, that's 25. Okay. And then negative 12 plus negative 6 is negative 18. All right, and that would be 6 for the row 3, column 1 entry, negative 18 for row 3, column 2, and positive 13 would be row 3, column 3 entry. Okay, and now you can check that with the calculator. All right, I've already did the transpose, so I would just need to do, all right, this. I would say, okay, I'm going to do matrix D, all right, and there's an implied multiplication, or you can hit the multiplication symbol if you want. Now, I can either do the matrix that I stored in matrix A, okay, which is the number 1, all right, and you'll see I'm going to get the same matrix that's sitting right here, okay. When I do that, I should get the 3 by 3 with 4, negative 8, 6 for row 1, which is what I've got here, negative 8, 25, negative 18 for row 2, 6, negative 18, 13. Now, by the way, you don't have to know how to save that as well. You could have just did T and did D, and then I don't even think you have to hit times, so I'm not going to, D, and then just do matrix 2, go to math and do 2, so matrix transpose to make it look exactly like what's on this piece of paper here, and you'll get the exact same thing, if I'm not mistaken. 4, negative 8, 6, negative 8, 25, 8, negative 18, 6, negative 18, 13. There you go. So you can do it either way. All right, moving on. Let's create, it says create a 2 by 2 matrix, a 3 by 3, a 5 by 5 identity matrix. Okay, well, the identity matrix has the column coming from top left down to the top bottom as just ones, and everything else is 0. So what I mean by that is this. Okay, so 1, 0, 0, 1 is the identity for the 2 by 2. Okay, that is I for all the 2 by 2 matrices. All right, for a 3 by 3, okay, that's what it wants next. You would have 1, 0, 0, 0, 1, 0, and 0, 0, 1. Notice that the diagonals from the top left down to the bottom right are all 1s. Everything else is 0. All right, for the 5 by 5. All right, so let's do this. For a 5 by 5, the first one would be 0. I mean 1, 0, and then 4 zeros. 2, 3, 4. All right, 0, 1, 0, 0, 0, and then 2 zeros, a 1, and then 2 zeros, and then 3 zeros, a 1 and a 0, and then 1, 2, 3, 4 zeros and a 1. All right, so this is the identity for the set of 3 by 3 matrices. This is the identity for the set of 5 by 5 matrices. Okay. All right, now the next question says, Are matrices A and B inverses? Demonstrate how you can tell. All right. Well, the rule for inverses, all right, is if you multiply them, you get the identity. Okay. All right. So when it asks, is A and B inverses, then we're going to need to multiply them and see. And by the way, that's a 2 by 2 times a 2 by 2. If we multiply those and get the identity for this set of 2 by 2s, which is 1, 0, 0, 1, then they will be inverses. Okay, so let's do that. If we want to do A times B, or oops, that's a bracket, we would need to do negative 3, 2, negative 7, 5, times B, which is negative 5, 2, negative 7, 3. All right. So that would, by the way, it's a 2 by 2 times a 2 by 2. That means you're going to get a 2 by 2. All right. So I'll just make room for a 2 by 2. Okay. Excuse me. Okay. So we would do negative 3 times negative 5 plus 2 times negative 7. We would do negative 7 times negative 5 plus 5 times negative 7. All right. And then we'll do negative 3 times 2 plus 2 times 3. Okay. And we're multiplying by this one. So that would be negative 7 times 2 plus 5 times 3. All right. So this would be equal to, all right, make my room for my 2 by 2, by the way. This first product is, and by the way, you're going to have to do both. You're going to have to do A times B and B times A in order to figure out if it's an identity. I forgot that. I'm sorry. All right, we'll check this one first. Okay, so this would be 15. So 15, and that would be minus 14. All right, this would be negative 6 for the first product and positive 6 for the second. This would be 35 minus 35. And down here we would get, let's see, negative 14 plus 15. All right, so let's see what we get here. All right, this 15 minus 14, that is a 1. All right, and these two are opposites, and if you add opposites, you get 0, and that's the same case in row 2, column 1. All right, and negative 14 plus 15, that's positive 1. So far, so good. So next we need to do B times A. All right, so we're going to reverse the order of these because we have to know that A times B and B times A are both equal to the 2 by 2 identity for matrix A and matrix B to be inverses, and that's how you can tell. Okay, so let's reverse them. If we reverse them, we have negative 5, 2, and negative 7, 3. All right, and negative 3, 2, and negative 5, 7. All right, so then we're going to reverse them, and we're going to set up for our 2 by 2 because that's what we're going to get. Okay, so this would be negative 5 times negative 3. You see that? Okay, plus 2 times negative 7. Okay. All right, and then negative 7 times negative 3 plus 3 times negative 7. All right, and then we'll do the second column here. We would do 2 times 2. Excuse me. Did I do that right? No, that's supposed to be negative 5. Excuse me. I got distracted. All right, so we're doing this one. It's supposed to be negative 5. I didn't do that right at all. Negative 5. So we're doing this row times that column times 2. All right. Plus 2 times 5. All right. And then down here, we would do this column times that second row, which would be negative 7 times 2 plus 3 times 5. All right. So let's see what we get. Oh. Okay. So this product would be 15, okay, 15. This product would be negative 14, all right. This product is 21, and that product is negative 21. This product is negative 10, and that product is positive 10. Okay, this product is negative 14, and that product is positive 15. All right, and then when we combine and add, we get 1 for the row 1, column 1. Row 1, column 2 is 0. This is also 0, and that right there is 1. And that way we checked, and yes, they are inverses of each other because A times B and B times A are both equal to the 2 by 2 identity, which is what sits right here. Okay, let's turn the paper. This is a lot, but this is what you learned in Algebra 2, by the way. So shouldn't be too much. All right, the next problem says, determine possible values for A and B that would make the following matrix statement true. Okay, well, if we multiply, all right, we've got a 2 by 2 times a 2 by 1, and that's equal to, it's possible since those are equal, it's going to be equal to a 2 by 1. So a 2 by 1 is what we're going to end up with. So we would, if we want a 2 by 1, that would look, we got 2 rows and 1 column, so we don't need to separate our columns. I could have made that smaller, but I need some room anyway. So we would do this row times that first column, so 2 times A plus 2 times 6, and that's going to be equal to what we have over here, which is 2B. Okay, all right, and then we're going to take this first row and multiply it times the second column, so that would be 2A plus 1 times 6, all right, and this would simplify, all right, and it would simplify. By the way, now we've got a 2 by 1 equal to a 2 by 1 over here. That means the corresponding entries are equal. So I'm going to simplify this first one right here to 2A plus 2 times 6 is 12, and that still has to equal that 2 right there, okay? While I'm at it, I'm going to go ahead and solve that, all right? I'll solve that by subtracting 12 on each side. That would tell me that 2A is equal to negative 10. I'll divide by 2, and that would tell me that A is equal to, excuse me, so, oh, wait a minute. That's supposed to be, oh, that is a 2. Okay, yeah, that would be fine. That A is equal to a negative 5. Okay, so there's your A value, negative 5. All right, now, I come over here and I take this one, which is 2A plus 6. So 2A plus 6 has to equal B. Okay, well, I know A is negative 5. So I would do 2 times negative 5 plus 6 is equal to B. Well, 2 times negative 5 is negative 10, and negative 10 plus 6 is negative 4. So there's your values for those two variables. All right, let's go to number 14. It says, determine possible values for A, B, and C that would make the statement true. Well, here we have a 2 by 2. Can you see that? Yes, you can. And we're going to multiply that by a 2 by 2, and that should give us a 2 by 2, which it does. Okay, all right. So let's come over here. We want a 2 by 2, so I'm going to make it kind of big here. A 2 by 2. Okay. All right. So we would take this first column of the second matrix and multiply it times the first row. So that would be 4A plus 1 times 2. All right, or 4A plus 2, okay? And then we'll do this first column times that one, so that would be 2A plus 3 times 2. Okay, and then we'll take this second column and multiply it times the first row, so that would be 4 times 6 plus 1 times B. I'm just going to write B, because 1 times B is B. Okay, and then 2 times 6 plus 3 times B. And this has to equal that 2 by 2 on the right over there. All right, okay. Now, we can see immediately that 4A plus 2, all right, I'm going to write that down here, 4A plus 2, that's row 1, column 1 entry, it has to equal 6. Okay, if you subtract 2 from each side, 4A has to equal 4. Divide each side by 4, you see that A has to be equal to 1, so A is 1. All right, now let's find B. Okay, I've got a B here, all right, and it'd be here. But if I use this b, I'm going to have to, I'll have an equation with two variables. I'd prefer to hold off on that until a little later. So I'm going to use this one. I'm going to say, okay, 4 times 6, that's 24. So I'll come over here and say 24 plus b, which is row 1, column 2 entry, equals row 1, column 2 entry over here, 27. I would then subtract 24 from each side. That would give me b on the left and 3 on the right. Okay, now I'm going to come down here, and that's the only place I see a C is row 2, column 2 entry. That's going to be equal to this one, which is 2 times 6 is 12 plus 3b equals C. But we know the value of b, so 12 plus 3 times 3 equals C. 3 times 3 is 9, so 12 plus 9 equals C, and 12 plus 9, that's 21. So there we have solved that for A, B, and C. All right. Next, determine the determinant, okay? The determinant means that you go down this product and then you subtract that product from it, okay? Or if you like, the determinant of a 2 by 2 matrix with A, B, C, D is equal to AD minus BC, if you like. You can write it that way. It's the same thing. Okay, so 4 times 3, here we go. If we want to find the determinant of a 4 by 3, and let's put determinant here, of a 4 by 3, let's see, 4, 5, 2, 3 matrix. I don't need that division. I don't have a fraction there. 2, 3, all right. That would be 4 times 3 minus 2 times 5, or 5 times 2. You can do it either way, which would be 12 minus 10. So that determinant is 2. All right, now on a 3 by 3, that's a little more difficult. What you have to do is repeat the next two columns, the first and second columns after that third. I'm just going to write that down right here, okay? And I'm going to use the determinant symbol. That's the symbol right here. Instead of using the brackets, you just do 3, 0, 1. You just basically write down the matrix without with the determinant symbology, all right, if you like, and then you repeat column 1 and column 2, okay? All right, and then what you do is you come down with these products right here, okay, with these products right here, that one, and that one, and then you subtract these products going up, okay? All right, in other words, these, let me do those ones coming down. So the ones coming down would be 3 times 2, which is 6, times this, which is also 6, so that would, and you'll add that, 36, and we're going to find that sum. And then 5 times 3 times 1, that's 15, so plus 15. And then negative 1 times 0 times 1, that's 0 times 1, which is 0. And then we're going to go up. 1 times 2 times negative 1, that's 2, negative 2. Okay, all right, negative 2, all right, plus we're going to do 4 times, let me make sure I get this right. Okay, we went 1, 2 there, we went 4 times 3 times that, that's 9 to 36, okay, so 36 plus, and then we're going to do 6, I believe that's a 6, isn't it? Can't even read one right, times 0 times 5, that's 0, yes, okay. So this would add up to 41 plus 10, which is 51, minus, let's see, that's 34, okay, 34, that would be equal to 6 to get to 40, 11 and 6 is 17, okay, so there you go, that's 17. All right, and you can do that on the calculator as well. I think there's a DTE in there, determinant, all right. You can check that on your own. I'll let you do that. Now, to find the inverse, all right, if you have a 2 by 2 matrix and you want to find its inverse, all right, let's call this matrix A for a second, all right. If you want A inverse, that's the symbology that we use with the little negative 1, all right. It's not a power, it's just inverse. That's equal to 1 over the determinant of A, all right, times, all right, now you switch A and D. So D goes here, A goes here, and then you change the signs on B and C. That's what it looks like right there, right there. Okay, so we're going to do 1 over, we do determinant, 4 times 3, all right? 4 times 3 is 12, okay? So 12 minus 5 times 2 is 10. So that's 1/2 basically is what that equals to. And then we're going to switch them, okay? All right, when we switch, 3 and 4 get switched, all right? And then we change the signs, okay? All right, we change the signs on C and B, all right? So -5 and -2, all right? Which would be equal to 1/2, that's a scalar, by the way, 3, -2, all right, -5, 4. All right, so we multiply this scalar times each term. 3 times that, that's going to give us 1.5 or 3/2, right, whichever one you want. And this times this would be -5/2 or -2.5. And 1/2 times this would give you -1, okay? And then 1/2 of 4 is 2. And there's the answer right there. All right, 3/2 for the row 1, column 1 entry, -1 for row 1, column 2 entry, and -5/2 for row 2, column 1 entry, and +2 for row 2, column 2 entry. All right, now do the same thing for that next one. I'm just going to real quickly do that. That product is 12 minus that product is -12, it's 24. So that determinant, okay, 6 times 2 minus 4 times -3 is +24. That's your determinant. So this would be equal to 1 over 24 times exchange A and D, so 2 and 6, change the sign on B and C, all right, and that would give you 1 over 24 times 2, 3, -4, 6. So we'll multiply times 2 first to get this row 1, column 1 entry. That would be 2 over 24, which is 1/12, by the way, okay, all right, and if we multiply this times 3, that'd be 3/24, which is 1/8, okay, all right. And if we do this, that's going to be -4 over 24, which is -1/6. And then this times this would be -1/4. Oh, +1/4, excuse me, +1/4. And there is your work for that one. Okay. On the weekend, the Goxfield Theater reported the following ticket sales for 3 first-run movies. As shown in the matrix at the right, if ticket prices were $6 for each adult, okay, and $4 for each child, what were the weekend sales for each movie? Okay, all right, well, what we're going to do is we're going to create another matrix, for adults and children, okay? And if this is a 2 by 2 matrix and we want to multiply it, it's got to be a 2 by something. So we're going to do 2 rows and 1 column, okay? All right, so what we're going to do is we're going to do the adults here and the children here, or child, all right? And that'll give us a 2 by 1 matrix that we can multiply this by, okay? And by the way, if you put this in, it says, I believe they gave you the dollar. This is the cost, really. Dollar amount for each ticket is what it is. The adult ticket costs $6, all right? And the child's ticket costs $4. So there's what we're going to multiply this matrix by. Okay, so what we would do is we would say, okay, 1,021, 25, 47, and 36, 52, okay, and 5, 2, 3, 7, 8, 5, and 24, 5, 6. We're going to multiply that times 6. Whoops, I don't need it. We're not doing a fraction. I don't know why I keep thinking we're doing fractions. 6, 4. Okay. Now, for something like this, I would expect you to go ahead and use your calculator, all right? So I'm going to put this one in A and that matrix in B, and then I'll do A times B. It's important that you do the right order. Now, before I do anything, though, I'm going to clear that RAM, because if I don't, I've got stuff in there that might mess things up, so I'm going to just clear the RAM, okay? And I'm going to do second matrix, and I'm going to edit matrix 1. Okay, how many rows do we have? We have 1, 2, 3. So it's a 3, and how many columns? That's 2. 3 by 2. And you'll see you got the same number of positions that your matrix has here. This first one was 1021. That's row 1, column 1 entry. Row 2, column 2 entry. Row 1, column 2 entry was 523. All right. Row 2, column 1 was 2547. And row 2, column 2 entry was 785. Okay. And row 3, column 1 entry is 3652. And row 3, column 2 entry was 2456, I believe it is. Okay. And then I'm going to do second matrix, or second quit to get out of the matrix editor. I'm going to put this cost matrix in. Okay. The price matrix, I should call it. I'm going to put that, we're going to edit number 2. So edit number 2. It is a 2 by 1 matrix with $6 being the cost of an adult ticket, $4 being the cost of the children's tickets. Okay, so now I can do A times B. So I'll do second matrix A and then times. You don't have to hit anything. I believe it's going to take care of it for us one way or the other. Okay. All right. And then when I come back, all right, it gives me, all right, 821A for row 1, column 1 entry, 18422 for row 2, column 1 entry, and 31736 for row 3, column 1 entry. And those are the amounts of money that each movie received. All right. So movie 1, all right, movie 1 brought in a total of $8,000, $8,218. Movie number 2, whatever that movie was, brought in a total amount of money of $18,422. And movie number 3 brought in a total dollar amount of $31,736. All right, I hope you do okay. If you have questions, give me a call, email me, or show up in your Google Meet. Thank you. Bye.